Welcome to the Deep Dive, brought to you by Safety One Source.
That's right.
Today, we are going deep on OSHA's timber shoring guidelines for trenches. We've got the must-know info from Appendix C of Subpart P to help you prevent cave-ins.
That's right. We're going to cut through all the regulation jargon and give you actionable knowledge that you can use in the field.
Absolutely, Nat.
Because at the end of the day, that's what matters most.
Yes, and this appendix is specifically about timber shoring for trenches up to 20 feet deep.
Right.
So if you're a safety pro dealing with trenches, you know how crucial this is.
Exactly. Deeper trenches require specialized engineering that go beyond these guidelines. And remember, timber shoring is just one option.
Right.
OSHA allows other protective systems too.
Right, like sloping, benching, or even shielding those trench walls. We'll save those for another deep dive. But before you even consider any method, the source material is adamant about one thing. Know your soil.
Know your soil. It's the foundation literally of everything.
Right.
Appendix A of Subpart P outlines how to classify your soil into type A, B, or C, each with different strengths and behaviors.
Okay.
Imagine trying to shore up a trench in loose sand the same way you would in dense clay. That's a recipe for disaster.
Okay, so you've classified your soil now. What?
Now you go to the tables.
Okay.
OSHA gives us these handy tables in Appendix C. Think of them as your shoring cheat sheet. They lay out exactly what size timber you need based on the trench depth, with soil type and the spacing you choose for your cross braces.
Wait, so we get to choose the spacing?
There is some flexibility, which is great for adapting to different site conditions. You choose the horizontal spacing for your cross braces, then the tables tell you the dimensions for everything else. The braces uprights and the horizontal beams called wales that support the uprights.
So it's kind of like a choose-your-own-adventure.
Exactly.
But for trench shoring?
Exactly. You get options while staying compliant. Let's say you've got a 13-foot deep trench in tight B soil, and you decide on a 5-foot width for your shoring. The table for type B soil actually gives you 3 different timber arrangements to choose from.
Interesting. So each option would have different dimensions and spacing requirements based on those choices?
Exactly.
That's pretty practical.
It is.
But what if you encounter a situation that isn't in the tables?
Right.
Like what if there's water in the trench?
That's where it gets trickier. These tables are meant for the most common scenarios if you've got heavy loads nearby surcharge from equipment or water in the trench. You'll need a custom designed system from a qualified engineer.
Makes sense. Safety first.
Safety first.
Speaking of those tricky situations,
the
source material calls out some key details to always keep in mind. For example, it emphasizes that those horizontal beams, the wales, need to be installed horizontally.
It seems obvious, right? But in a fast-paced work environment, it's easy to overlook these things. And a misaligned wale can compromise the entire system.
Absolutely. And if the distance between the trench bottom and that lowest cross brace is too much, you need to either embed those vertical uprights into the soil or use a mud sill for extra support.
It's like an anchor for your shoring system.
And speaking of water, we can't forget about tight sheeting.
Yes, tight sheeting.
Tell us more about that.
When water is present, it can seep behind your shoring, washing away soil, causing instability. Tight sheeting uses special timber planks with tight edges or even steel sheeting to create a barrier. It's all about preventing water from flowing through and eroding the soil that's supporting the system.
So it's like a watertight wall within the trench.
Yeah, you can think of it that way.
But the source material also mentions something called close sheeting. What's the difference between those two?
Good catch. While both involve placing timber planks side by side. Close sheeting is less about being completely watertight. And more about minimizing gaps to prevent soil from slumping through. Think of it as general reinforcement versus a water barrier.
So tight sheeting for water, close sheeting for general soil stability.
Exactly.
I'm starting to get the hang of this, and it seems like OSHA really emphasizes having those uprights as close together as possible in those situations.
Yes.
Why is that?
Because the closer those uprights are, the less chance there is for soil to move around behind the shoring system. It's all about creating a tight and supportive barrier.
Gotcha. Now, I know we've thrown a lot of information at you already.
We have.
But before we move on to some other important points, I want to take a step back and talk about why all of this matters.
Absolutely.
We're not just talking about regulations here. We're talking about people's lives.
people's lives, exactly.
Trench collapses are a serious hazard on construction sites and a leading cause of fatalities in the industry. OSHA has these strict shoring guidelines to prevent those tragedies.
That's right.
And the timber sizes OSHA recommends in those tables aren't arbitrary. They're based on extensive research from the National Institute of Standards and Technology, or NIST, on timber strength.
Exactly.
So there's real science behind those dimensions, not just random numbers.
Real science.
That's good to know. And speaking of dimensions, the source material made a point of saying that the tables use actual timber dimensions.
Right.
Not nominal ones.
Yes.
What's the difference?
Remember, lumber dimensions can be tricky. Those 2x4, 4x6 labels you see at the store.
Yeah.
Those are nominal dimensions, the rough size before the lumber is dried and planed.
Different.
Actual dimensions are slightly smaller.
So a 2x4 isn't actually 2 inches by 4 inches?
Nope. The actual dimensions are closer to 1.5 inches by 3.5 inches.
Well, that's a bit misleading, isn't it?
It can be. That's why OSHA emphasizes using the actual dimensions when selecting timber for shoring. You need those precise measurements to ensure the right strength for the job.
Okay, so double check those measurements before building your shoring system.
Yes. Always double check.
And I know we've been talking a lot about the specifics.
Right.
But I want to shift gears for a moment and talk about another valuable tool in shoring systems.
Okay.
Trench jacks.
Trench jacks, good point. They can be incredibly useful either replacing or working alongside traditional cross braces.
Yeah.
It depends on the situation and what the engineer designs.
So tell us, how do trench jacks work?
Think of them like giant adjustable clamps for your trench walls.
Yeah.
They use hydraulic pressure to expand, pushing against the uprights and creating that essential horizontal support.
That's fascinating. So they're essentially using hydraulics to hold the trench walls apart.
Exactly.
Interesting.
One of the big advantages is that they can be adjusted easily.
Okay.
This is super helpful when you're working with variable soil conditions.
So more flexibility in the field, got it. But I imagine there are some limitations to trench jacks as well.
Of course, they need to be used correctly according to the manufacturer's instructions.
Right.
And they're not the right solution for every scenario.
Right. When in doubt, always consult with a qualified engineer.
Absolutely.
Speaking of consulting,
yeah,
is there anything else we should know before we wrap up this part of the deep dive?
We still need to cover some key notes and considerations from the source material that apply to all those OSHA tables.
Okay.
Things that might seem like small details, but can make a big difference in the safety and effectiveness of your shoring system. We'll save those for the last part of our dive today.
Oh, good.
Okay. Welcome back to the deep dive. Before the break, we were discussing some important considerations for those OSHA shoring tables.
Right.
Now, those tables lay out specific spacing for your cross braces, wales, and uprights.
Right.
But you're not completely locked into those exact measurements.
So there's some flexibility.
There is some flexibility.
That's good to know.
Yeah.
Because every job site is a little different.
Exactly. You can adjust the spacing to fit your site conditions or the materials you have on hand.
Okay.
But any changes have to be approved by a qualified engineer.
Of course.
No going rogue on your shoring setup.
Makes sense. Safety first. So what are some other details we should keep in mind when referencing those tables?
Placement of that top cross brace is crucial. OSHA has specific guidelines, depending on the vertical spacing of your braces. For instance, if your cross braces are 4 feet apart vertically, that top brace needs to be no more than 2 feet below the top of the trench.
Okay, 2 feet max for 4-foot spacing.
Right.
So it's all about making sure there's proper support as you get closer to the trench edge. What if those cross braces are spaced to 5 feet apart?
Then you have a bit more leeway.
Okay.
The top brace can be up to 2.5 feet below the top of the trench.
Interesting. So the higher those braces are, the closer that top one needs to be. It's like they're providing extra support where it's needed most.
Precisely. You want to maintain a consistent level of protection throughout the entire system, no matter the spacing. And speaking of consistent protection, remember those mud sills we talked about earlier?
Yes.
The horizontal timbers placed at the base of the trench?
Right, like an anchor for your shoring system, especially in those deeper trenches where those vertical uprights need extra support at the bottom.
Well, there are a few ways to install them. You can put the mud sill directly on the trench bottom or use it with embedded uprights.
Embedded uprights mean they're partially buried in the soil.
Exactly. And how deep those uprights are embedded, or if you even need them, affects the maximum distance you can have between that lowest cross brace and the bottom of the trench.
So there are limits on that distance?
Absolutely. If you're only using a mud sill, that distance can't be more than 42 inches.
Okay.
But if you're embedding those uprights, you get a little more leeway up to 36 inches.
So embedding those uprights gives you more flexibility with that vertical distance. It makes sense that if those uprights are anchored in the soil, they can handle a bit more.
Right.
It's really amazing how much detail OSHA has considered in these guidelines.
It really is. They've thought of just about everything to keep workers safe in these dangerous environments. But as comprehensive as Appendix C is, there are a few other things that the source material emphasizes to ensure a safe trench.
Like what? Fill us in.
Well, the first is making sure that the timber used for your shoring is sound and free from any defects that might compromise its strength.
Okay.
You don't want to be using wood that's rotted, cracked, or otherwise damaged.
Right. That sounds like common sense.
It is.
But it's easy to overlook things when you're under pressure on a job site.
Exactly.
What else should we watch out for?
Another critical point is proper installation.
Okay.
The source material stresses the importance of making sure those shoring members are plumb and in firm contact with the trench wall.
Okay.
Any gaps or misalignments can weaken the system.
So it's not just about having the right materials, it's about putting them together correctly.
Exactly. And remember, those cross braces need to be securely fastened to the uprights.
Oh, of course not.
You don't want them coming loose under pressure?
It seems like all of these seemingly small details are crucial for a safe and effective shoring system.
They are.
Is there anything else we should be aware of?
One more thing. The source material highlights the importance of ongoing inspections.
Okay.
Trenches are dynamic environments, and conditions can change over time.
So you're saying that just setting up the shoring and walking away isn't enough?
Right. Regular inspections are vital to make sure the system remains stable. You need to watch for any signs of movement damage or deterioration.
It makes sense things can shift and settle, especially after rain or changes in temperature. So what happens if you spot a problem during an inspection?
Any deficiencies need to be addressed promptly. Whether it's a loose brace, a damaged upright, or signs of soil erosion, take action immediately to fix the problem before it becomes a safety hazard.
Okay.
Remember, Appendix C provides those initial guidelines.
Right.
But ensuring ongoing safety requires vigilance and proactive measures.
Well said. We've covered a lot of ground today, but I'm sure there's even more to explore in this topic. But, yeah, it really is fascinating how just one little detail can make a big difference in keeping those trenches safe.
It all adds up.
It really does.
Yeah.
So as we wrap up this deep dive,
Okay.
what final thoughts or key takeaways do you want to leave our listeners with?
I think the most important message is this trench safety is a shared responsibility.
Okay.
It's not just on the engineers, the supervisors, or the workers installing the shoring.
Right.
Everyone on that job site
Yeah.
has a role to play in keeping each other safe.
That's such an important point. It's about communication, vigilance, and a culture of safety.
Yes.
That permeates every level of the operation.
Exactly. Speak up if you see something that doesn't look right.
Yeah.
Ask questions if you're unsure about something. And never be afraid to stop work if you feel unsafe.
Yeah.
Your life and the lives of your colleagues depend on it.
Absolutely well said. And remember, those OSHA regulations are a minimum standard.
Right.
You can always go above and beyond to create an even safer work environment.
Absolutely. Think about additional training for your crews, invest in higher quality materials, and explore new technologies that can enhance trench safety.
Great advice. So to recap, we've explored the ins and outs of OSHA's timber shoring guidelines.
We have.
We've learned about soil classification, those all-important tables in Appendix C, the nuances of timber selection, and the importance of ongoing inspections.
We've also talked about alternative protective systems, the role of qualified engineers, and the crucial role that every individual plays in maintaining a safe trench.
It's been a deep dive indeed, and a huge thank you to Safety One Source for making this episode possible. Be sure to check out their website for more resources and training materials on trench safety and a whole host of other workplace safety topics.
They're a fantastic resource for staying informed and keeping your workers safe.
Thanks for joining us on the Deep Dive. We'll be back soon with another deep dive into a topic that matters to you. Until then, stay curious, stay informed, and most importantly, stay safe.
Stay safe.